morning everyone. Today we are going to learn one important error correction method which is called as Hamming code. Now till now whatever methods we learned like single parity check, longitudinal parity check, or we learned about cyclic redundancy check, all these methods or checksum, all these methods are used only for detection of error. In the sense we try to check whether there is any error in the data unit that was sent from the sender to the receiver. We do not come to know the place where the error is occurred. We just come to know whether the data frame is erroneous or not erroneous. So whether it is single parity check or longitudinal parity check, you don't come to know the position of the bit where the error has occurred, or which bit has got changed from 1 to 0 or from 0 to 1. And that's why all these methods that we learned till now, they are only serving the purpose of detecting errors. That is why also they are called as error detection methods. But sometimes when you are transmitting data over long distance, what might happen is it may not be possible to retransmit the data again and again. In such a case, it is going to be difficult to only detect the error and ask for retransmission of data. And hence, most of the times for long distance transmission, or maybe for satellite transmission, or maybe where retransmission may not be possible on and often, we require mechanisms not only to detect the error but also to correct the error. So we must know what is meant by the term error correction. Error correction refers to 11-bit sequence or in the data unit that we are transmitting, we are going to place these redundant bits at different positions which are nothing but powers of 2. So how are we going to place them? Suppose this is your data unit. Now our data unit at original data unit has 7 bits plus the new redundant bits, that is 4 bits. 7 plus 4 is going to make it 11. Total 11 5, 7, 9 and 11. 1, 2, 3, 4. 4 ones are there. That means what should be the parity? Even number of ones, no? So parity will be equal to 0. Okay? Now see R2. R2. R2 is responsible for which sequence? 3, 6, 7, 10, 11. Okay? So 3, 6, 7, 10, 11. How many ones are there? 1, online class. We will discuss both, and if you have any doubts or any clarifications you need, that I